I'll continue on integration by substitution, but today we'll be focusing on how to actually use the reverse chain rule more instead of using the substitution U. Hopefully you have done the homework I set up, the worksheets for yesterday. So let's start with a revision question. Integrating, let's say 12x squared brackets x to the power 3 plus 12 to the power of 5 dx. Okay, so now recognizing this is the target function, this is kind of the component. All right, so the derivative of x cubed plus 12 is just 3x squared. And that's exactly what you need because that is the component. 3x squared, x cubed plus 12, 5 dx. Okay, right, and remember we can't change the question. To get from 3 back to 12, also you need to multiply by 4. So now it's ready. 4 multiplied by x cubed plus 12 to the power of 6 over 6 plus c. 4 on 6, that's 2 over 3. Plus c. Alright, so this is just a quick revise on reverse chain rule. However, now here is what reverse chain rule actually said. If I'm integrating power function only, version, power function version. Why is power function version only? Because we'll be dealing with other types of functions very soon. If I want to integrating the whole function to the power of n, which is something like x cubed plus 12 to the power of 5 in this case, we can't just do it straight away. We actually need the component. If this is our target function, the component is defined by the derivative of such function. If this derivative is provided, in other words, if this component is provided, we can go straight to integrate this as a whole thing, which gives you fx to the power n plus 1 over n plus 1. So this is actually the reverse chain rule in actual function notation. So again, if you are provided with a component, you can do the integration as a whole thing. We'll do a few examples in here. Let's say integrating from mx, that is nx squared minus 5 to the power of 6 dx. Okay, so this is a good illustration about how do you manipulate a constant to get your actual thingy. So just go straight to write down your component. Your component is a derivative of the function inside, which is 2nx. nx squared minus 5 6 dx. Now you have to balance the question. First of all, the m should be just taken out. It has nothing to do with the component. It is not the constant you want, so we take it out. And you just multiply 2n by out of the blue. So therefore, outside you can multiply by 1 on 2n. In other words, you can check this by just multiply this constant back into this integral. See if you can just get mx at the front. If you can, you have done the right thing. If not, then you make some mistake. So m on 2n outside. Now this is ready to be integrated. In other words, you can treat this as whole fx multiply by to raise to the power of 7 divided by 7. Therefore, which is m nx squared minus 5 to the power of 7 over 14n plus 6. Alright, so remember, the way to do actual reverse chain rule is actually just to recognize which one is the target function, which one is your component. Remember, if the question forces you to do integration by substitution, you can't use reverse chain rule. You have to use the U way. If the question doesn't stay in that way, you can either use the reverse chain rule or integration by substitution. It's up to you. Personally, of course, I prefer reverse chain rule because it's easier. Alright, so now let's take a look at some more examples, see how we go. Especially, I would like to do a few more with you with the square root. So, for example, again, if I have integrating 2 root x, let's just make it 5 root x minus 2 to the power of 5 over root x dx. Why do I always need to have a 1 over root x here? Because the derivative of root x is 1 on 2 root x. Alright, so now the 5 has nothing to do with the component. Well, in this case, when you differentiate 5 root x, that should give you 5 on 2 root x. But we don't have 5 on 2 in this case, obviously, so therefore we just need to make it 5 root x minus 2, 5, 2 root x dx. Now, this is the component. That's what you need for the integration as a whole thing. And of course, as usual, you can't actually just write this. You need to balance that out because you have none of these. Oh, sorry about that. That should be 5 root x minus 2. Alright, and now you have balanced the question. 2 and 5 stays. Now, with the component, you can actually do this whole thing as treated as a whole function. And then that will give you 5 root x minus 2 to the power of 6 over 3, 5, 15 plus c. Okay, remember, with square root is always a little bit challenging because it's not that easy to see the component. However, sometimes with fractional indices, with negative indices, it's a little bit hard to recognize. For example, if I have 1 x minus 5 to the power of 6 over square dx. So obviously this is the target function. So how does this relate to be a component? Because if I differentiate this is x to the power of negative 1, bring negative 1 down, and then x to the power of 2 at the bottom. So therefore, that's kind of the component, but you don't have the negative. Therefore, we need to manipulate. And that's negative at the front. So therefore, that gives you 1 on x minus 5 to the power of 7 over 7 plus c. Remember, this is the component. Now, I keep mentioning which one is the component is to try to get you more familiar with how to identify the target function and how to identify the actual component itself. Let's do a few more. Let's do definite integral. So if from 0 to 8, x over ax squared plus 1 squared dx. Now in this case, you need to treat the bottom function ax squared plus 1 to the power of negative 2. And the derivative of this part is 2ax. Well, obviously we don't have that as our component, so therefore we need to make it 2ax ax squared plus 1 to the power of negative 2 dx. And then, of course, you don't have 2a. You didn't have the 2a. Now you need to balance it out. Now, everything go as usual. Integrate this as a whole function. That becomes ax squared plus 1 to the power of negative 2 plus 1 is negative 1 divided by negative 1. And then we need to substitute in from 0 to a. Take out the negative 1 as a common factor. Sorry, anything. And then that is ax squared plus 1 to the power of negative 1. Substitute from 0 to a. Now, you can do what I did before by putting the negative in to swap the boundary. That's what I normally will do. Ax squared plus 1 to the power of negative 1. Swapping the boundary. Put 0 in, that's 1. 1 to the power of negative 1 is 1. Put a in, minus. Put a in, a to the power of 3 plus 1. Oops. What was that? Oh. What? Oh, come back to this. Sorry. So 1 to the power of negative 1 is 1, obviously. And then put a in, a cubed plus 1. So therefore reciprocal, so that's a cubed plus 1. Okay, if you make a common denominator, that becomes a cubed minus plus 1 minus 1, that's a cubed at the top, 2a at the bottom, that's a cubed plus 1. That's just a simple algebra bit of here. All right, now these are all examples of reverse chain rule. Again, in reverse chain rule, you don't need to change the boundary because the whole question remained as the variable as x. We haven't done any u, so therefore you don't need to update the domain in this case. All right, let's do one more. Integrating from 0 to half x square root of 1 minus 4x squared dx. Now, the derivative of the inside function should be negative 8x. And you write this as 1 over 2x to the power of half dx. Again, you can't just do this. You need to multiply outside by negative 1 on 8 to balance the question out because the question only provides x instead of negative 8x. Now, that becomes 1 minus 4x squared to the power of 3 on 2 divided by 3 on 2. Substituting. Sorry, I forgot the boundary. Yeah. Gemma, I know you're going to say something. All right, 0 to half. Now, put the boundary out, divided by 3 on 2, that is multiplied by 2 on 3, so cancel. That's negative 1 on 12. So we'll swap the boundary again. That's 1 minus 4x squared, 3 on 2. By swapping boundaries from half to 0, instead of 0 to half. Sub 0 in, that's 1. Sub half in, that is half times 4, 1 minus 1, 0. And that gives you 1 12. Right? Let's do one last one. Integrating b squared to 4b squared. Again, this time involves square root x plus b squared on root x dx. Now, in this case, remember the derivative of the inside function, which involves the root x, it's 1 on 2 root x. So therefore, that's the component. Of course, that requires your derivative skill to be solid, and because you have multiplied that by half, yes, and then you also need to multiply by 2 to actually balance the question. And again, now this part is the component. That is 2 root x, as usual. Right, so therefore, we can treat it as the whole thing now. X plus b to the power 3 on 3, substituting b squared on 4b squared. And 2 on 3 out. Let's substitute root x plus b to the power 3, b squared to 4b squared. Substituting in 4b squared, that gives you 2b. Oops. 2b plus b, that is 3b. 3b to the power of 3, that is 27b cubed. So that is the result when you substitute 4b squared in. You substitute b squared in, square root of b squared is b, b plus b is 2b, 2b the whole to the power of 3, that's 8b cubed. 27 minus 8b. 27b cubed minus 8b cubed, that is 19. 19b cubed multiplied by 2 on 3, that is 38 on 3b cubed. Okay, that's how you do reverse chain rule. Remember, if the question asks you to do integration by substitution, you have to. See you, bye-bye.